Okay, so this is example 5, 6, or lesson 5, 6, example 4, solving equations using substitution. And first of all, I want to look at this equation here, x squared plus 5x plus 6, and a little reminder that when we're solving these equations, we want to use factoring if we can. And one of the keys is the fact that we have x squared and 5x to the first power, that the exponent for the first term is always double the exponent for the middle term. And we can factor this and get x plus 2 times x plus 3, that quantity equals 0. Or we could look at a situation like this, where it's still the first exponent is double the second term's exponent, and we could factor that as x squared plus 3 and x squared plus 2 equals 0. And so we're going to use the same type of thought process with the substitution, except we're going to go ahead and with our substitution, we're going to let u equal whatever the middle term variable is. In this case, that would be e to the x. And so if we look at it, then we have the first term would be u squared minus u minus 20 equals 0. So we can actually solve this equation now. It makes more sense using the u's here, and because we just see something squared in u, where the e to the 2x makes it a little more difficult. So now I can factor this and say it's u minus 5 times u plus 4 is equal to 0. So u equals 5 or u equals negative 4. And then once I get to this point here, then I'll go ahead and substitute my original part back in. So we have e to the x equals 5 or e to the x equals negative 4. Now then, to solve this equation, we just need to take the natural log. So x would equal the natural log of 5, and x would equal the natural log of negative 4. Well, for x equals natural log of negative 4, there's no solution there because we cannot do the natural log of a negative number. So this part produces no solution. It's undefined. And then my answer over here for this other part then is just going to be the natural log of 5, or you could take your calculator and type that in, natural log of 5, and we could say it's 1.609 approximately. And that would be our answer.